Hello everyone, welcome back to my channel Code with Khan. Let's say today's Leetcode problem, which is Trionic Array level 2, which is marked as hard. So we are given an integer array nums of length n. So a Trionic subarray is a contiguous subarray from nums of L to R with 0 is less than or equals to n and L is less than or equals to R and R is less than or equals to n, for which there exist indices L less than P, P less than Q and Q less than R, such that nums of L to P is strictly increasing, nums of P to Q is strictly decreasing, and nums of Q to R is strictly increasing. So let's simplify this question. So in yesterday's question, they have said that, so in nums array, we need to check from 0 to n minus 1, like till the end, if it is follows this pattern, right? Increasing, decreasing, and then increasing pattern. So we need to check if it is follows this condition or not. Now they're asking, in this question, they're asking that in the nums array, we need to find a subarray, right? In the nums array, we need to find any subarray, right? Any trionic subarray which follows this pattern, right? And we need to find its sum of elements. So it is possible that there can be multiple trionic subarrays, and we need to find the maximum sum of elements of that trionic subarray. So I think you understand the problem. Now let's check the constraints. So constraints are nums.length is 10 to the power of 5. Okay, so if it is 10 to the power of 5, we cannot go with n square approach, n cross n approach. So we need to look for an approach which is less than n square. Okay, so it is guaranteed that at least one trionic subarray will be exist in the nums. Okay, let's see with an example. Let's see with one example. Here we are given with one nums array, right? So let's check the brute force approach first. So what is the brute force approach? So we will try to generate all subarrays, right? Like if this is one subarray, and we will try to check like this, we will try to generate all subarrays. So but we know at least to be trionic subarray, we need at least 4 elements. Why? So if we have 1, 2, 3, not 1, 2, 3, let's take 3, 4, and 2. So 3 to 4 is increasing, but 4 to 2 is decreasing. To have another phase, the increasing one, so we need at least one more element, right? Which is 6. If we have at least 4 elements, then only we will be able to find this increasing, decreasing, and then increasing phases. Okay, so what we will do is we will try to create the subarrays of length at least 4, and then we will try to create the subarrays, and then we will check if that subarray is trionic or not. If it is trionic, then we will find the sum, and we'll find the maximum of from the all sums of the trionic subarrays. So to generate all subarrays, it takes n cross n, right? We need 2 for loops to generate the all subarrays. So which is constraint is nums.length can be 10 to the power of 5, so we cannot use n cross n approach. So what is the better approach? So let's see the better approach. So if we cleanly observe here, so from 0 to minus 3, so we are trying to check if it is trionic or not. And then from 0 to 0 again, so from this, if we know 1, 2, 3, 4, 5, 6, from 0 to 4, what is changing number here? Only we are adding the 0, so we need to only check 3 to 0, right? For that reason, we are checking all these remaining array again multiple times, right? So if we want to find this subarray is trionic or not, we need to check all its previous elements, right? Previous part also we need to check if it is trionic or not. So if it needs to, same as this subarray also. So how we can solve is, so we will use states here. So we'll use 0 as not started state when we are not started anything, and 1 as increasing state, let's take it as 1, and 2 as decreasing state, and 3 as increasing to state. So here what we'll do is, when we are standing at index I, so in 0th state, what is its results? We'll store this one in a DP array, in DP matrix. When I am standing at I, what is its results in state 1, which is increasing state. When we are standing at index I in state 2, in decreasing state, if it is in decreasing state, what is its results? When we are standing at I, and if it is in increasing 2 state, which is state 3, then we will store that in the DP array. So what we can do is, so for each element I, right, we will try to traverse, right, like this, like this, like this, like this, and we will check if it is trionic or not, if it is follows this condition. When we are first at I0, right, we are at not started state, then we will check it with the next element, which is -2. Is it in increasing state? No, it is not in increasing state. It is not follows this pattern, so it should be in the order, right? It is not following the pattern, so we'll directly return from here. Now we'll increase the I. We'll go to I. From I we will try to generate the pattern. So from I is equals to 1, so we see I, and now state is 0. Now we will compare it with the next element, so which is 1, which is an increasing order, so it follows the increasing pattern. So we'll update state to 1. Now state became 1, and we are at second index. Now we'll compare it with the next element, which is -3, right? So which is the decreasing. That means we move to the second state. So from state 1 we move to state 2. Now we will check, move forward, and we'll see, is this element is in decreasing state? No, it is increasing state. That means it moved from second state to third state, so it came to increasing 2 state. Now we'll update the answer, and then we'll move further. So is this in the increasing state still? Yes, it is in the increasing state. Now we'll move further. Is this in the increasing state? No, it is not in the increasing state, and we'll straight forward return from the we'll add this to the sum, and we'll return. We'll add this to the sum, and we'll return. We'll add this to the sum, and we'll return. We'll add this to the sum, and we'll return. We'll add this to the sum. So what we'll do is, we'll start the traversal from I is equals to 0 with the state not started. We'll start the DFS where from I is equals to 0 and state is not started. So we'll try to find the trionic array from index 0, and we'll traverse, and we'll check if we found any trionic array or not. So when we are at state 0, right, if it is state 0, so we have two options. So either it satisfies the increasing order increasing state condition, or it doesn't satisfy this increasing condition. That is, if this nums of I is less than nums of I plus 1, right, if that satisfies this condition, so we are at state 1 now, right, we are in the increasing state. So we found one element which is nums of I is less than nums of I plus 1, so which is an increasing phase. So what we'll do is, we will find is there any other increasing elements further. So we'll increase the index, and we'll update the state to 1. So now we are in the increasing phase, so we will check further in the nums array. So do we have any other elements which are in the same state, right? So if it is not in the state, so we will return here itself. Okay, now the second case is, if we are at state 1, right, we are in the increasing state, so we have two options here. So one is, either we check for the same condition where nums of I is less than nums of I plus 1. So if it is following the same condition, same state or not. We need to check that. If it is follows, then what we'll do is we will pass the same condition. Okay, so we'll pass the same condition and we'll pass the same state. We'll update the index and we'll pass the same state. Now if it doesn't follows this state and if it changes its state, which is decreasing order, so we'll check if nums of I is greater than nums of I plus 1. So now it changed its state, right? Now till now we traverse the increasing state. Now we found a element which is the in the decreasing state. So we found this phase now. So we will update the state and we will traverse further. We'll update the state to 2 and we will traverse further. Okay, now if we are at the state 2, which is decreasing state, so here also we have two possibilities. One is we found the decreasing elements, we will traverse further, or we found the increasing state, we will change the state. So we will check if nums of I is still greater than nums of I plus 1, then I will traverse further with same state. Okay, or else if nums of I is less than nums of I plus 1, which is third state. Third state is nothing but increasing state. We found this condition. Now we'll update and we'll traverse further. We'll update it and we'll update the state as well, state to 3. So now when we are at state 3, which is increasing 2 state, in this condition we have two options, right? If we found till here, we found the pattern. Either we go further to check if any other elements follows this phase or not, increasing phase or not, or we can stop with this one. So either we will stop with this element or we can go further. I plus 1 and with same state. So and at the end we will update the DP array with the state, with the results. So this holds when we are at I in state 3. So for example, manlo when we are at I index 0, index 2, right, and state is increasing state, which is nothing but 1. So we have we are storing the some results. So that means in this if we are traversing for the second time, so we don't need to fetch again, right? So we need to add that condition. So we'll add it here. So if dp of I and state is not is equals to null, then we'll directly return dp of I comma state. Okay, and for this DFS traversal, what is the base condition? Base condition is if I becomes, we reach the end. If we reach the end, we need to check if it is in this state or not, state 3 or not. If state is double equals to 3, then we will return 0, otherwise we will return infinity. That means it is not following the this increasing, decreasing, increasing phase. Okay, let's see code for this one. Okay, let's start coding. So we will first take dp, initialize the dp array, right? So we will use long of dp, then we will use long infinity as long dot min underscore value. Since we want to find maximum value, so we will use the min here, and then we will to store length will take n. So these are the class level variables. Now let's initialize the values, nums dot length, and then dp is going to be new long of n plus 1, and then since we have 4 states, we'll use 4 here, and then we will initialize on long answer is equals to we'll need to take main value here. Answer is equals to long dot underscore value. Now so we will iterate through the array, and I is equals to 0 to I should be less than n, and then I plus plus. From each index we'll try to find the generate the trionic array. So answer is going to be math dot max of the answer, and we'll do the recursion. We'll start the traversal from I, and the state is 0 first. So now at the end we will return this answer. So now let's write the DFS method. So this public long DFS takes the we need nums array also, so let's pass the nums array as well, okay, to this function. Nums will take the integer array nums here, and then we'll use the index I, and then state 0, right? We'll use the state also, okay. What is the base condition here? So base condition is if our I is reached the end, then we need to check if our state is reached to the last state, which is second decreasing state, or not. If it is the last state, right, if it is the last state, then we will return the 0. Otherwise we will return enough, okay. And then this is base condition, and let's start with the conditions now. We will initialize the sum here. Let's take it as a result, and now if it is state 0, we are at the state 0. If state double equals to 0, that is we haven't started it. In that scenario we need to check if nums of I is less than nums of I plus 1 or not, that is it is in the decreasing order or not. And let's add the index condition also. I plus 1 should be less than n, and then nums of I should be less than nums of I plus 1. If this satisfies, that means we found the increasing order. Now what we will do is we will find the math.max of result comma, we will add this to the result, and we will traverse further. I plus 1 comma, we will increase the state to 1, okay. So this is the case. If it doesn't satisfy this condition, that means when we are at 0 we didn't find the increasing order. In this case we will directly return enough, okay. So now let's go to the second step, which is state 1. If we are at state 1, now two cases possible, that is if I plus 1 is less than n, and then our nums of I is still less than nums of I plus 1, that means increasing order is, we are still in the increasing phase. So if it is true, then we'll find the further increasing phase. Now math.max of result comma, we will add this to the result, and we will call DFS for the next index, and state will be the same state, okay. And then if this is the not condition, if this is the not this condition, if let's take else, not take else, if this is the condition, right, if I plus 1 is less than n, and if nums of I is greater than nums of I plus 1, That means we found the decreasing phase now. So what we'll do, we'll move further with the state as 2. So math dot max is result comma nums of I plus dfs of I plus 1. We will move further to the next index and we'll update state to 2. Now let's go to the next state, right? If we are at the state 2, which is the decreasing state, so now here also two cases possible, which is still follows the decreasing phase or it moves to the next increasing phase, that is increasing 2. Now here also we will check the same condition, and then if nums of I is greater than nums of I plus 1, so in this case we will simply move further with the same state, right? Method max of result comma, I am doing this, result comma nums of I plus 1 plus, we will move further dfs of I plus 1 with the same state 2. Otherwise, if this condition is failed, that means we found the increasing 2 phase. Now if I plus 1 is less than n and then nums of I is less than nums of I plus 1, then we will just update the state to 3 and we'll move further. Then dfs of I plus 1 comma state increase to 3 and the final state now, which is state 3. If we are at state 3, so we can stop with the current element, right, nums of I, or either we can go further, right, if it is satisfies the same condition. If I plus 1 is less than n and nums of I is less than nums of I plus 1, so it is satisfies this condition, so then what we can do, we can move further. There with this one, I will add this one with, will traverse further I plus 1 and then same state. Okay, so now what we will do is, at the end we'll update the dp state and we'll return it. So we'll return update the dp state with the result and we'll return the same. So here, and to use this memoization, so what we'll do here, we will add this on condition, that is if dp of I, so for I at this state we already have the values, right? If we already have the values, which is it is not is equals to null, then we can simply return that value. So if you have already calculated the ith state, I mean for ith index we already calculated for the state, so we will directly return that value. Okay, so we have went past this nums array, so let's pass this for the calls. We haven't passed this nums array, so we'll pass this to all dfs calls here, and then here, and then here also, finally here. So now I think it looks good. Now let's execute the code, right? Okay, we are getting not a statement. What we are doing, which line? Okay, I need to return it and just add this one. We need to return this. Okay, so now let's run this again. So we'll use the class here, so it will initialize the null values. So initialize with the long class, so it will use the null values, otherwise it will not take. So what I will do is, sorry, not this one, the status long only. I will initialize this with the long, and then I will check if I is not is equals to no. Okay, here we did something wrong, which we have to add nums of I, but we have added nums of I plus I. So now let's run this again. Okay, it accepted. Now let's submit. Yes, now all test cases got passed. Now please guys, like, share and subscribe to my channel. Thank you for watching. Happy coding.